Welcome to a What's New video in Hyperlinks DRC. This release of Hyperlinks DRC brings a host of updates and new features. The first is a new creepage wizard based off of our high voltage safety creepage rules and algorithm. Note the path in the installation of the tool to access the new creepage wizard. For users who have constraints built around creepage checking, this new wizard will streamline a large batch of creepage checks for each net class defined in layout. For Siemens EDA tool expedition layout, these constraints and classes are dynamically read in by Hyperlinks DRC. If you are using Hyperlinks DRC with another layout tool, constraints can be imported via a CSV file. Distance values can be edited from the creepage table in the wizard after they have been read in if necessary. Select the net classes and layers you want to run the creepage check on and generate a share list report to show any violations where high voltage objects are close enough to creep or affect potential victim nets on a PCB. Here is what the share list report looks like, showing values of the spreadsheet table that is natively in Hyperlinks DRC. Take note of the measured distance for creepage being under the minimum required distance for this spec, which results in a violation. Results show up in Hyperlinks DRC under the current run after running the new creepage wizard in 2510. Selecting a violation manipulates the board viewer to showcase where this violation occurs and what objects are potentially affected by the high voltage safety issue. The 2510 release brings rule area and constraint area support for layout tools. Here, in Expedition Layout, simply create a rule area object, and in this case, to run Hyperlinks DRC electrical rule checks on a targeted portion of your PCB. Here I have 5 DDR4 DRAMs on my board, and I will run electrical rule checks in this area of the board. Hyperlinks DRC can be launched directly from within Expedition Layout, and in 2510, Hyperlinks DRC can now import these rule or constraint areas. I will test this with the ICs over split rule, which checks that IC components have a solid reference beneath them. By running this rule and applying it to the whole design, I expect it to locate all 5 of my DRAMs, and the rule does. When I apply the rule to my custom rule area I created in Expedition Layout, I tag it to include objects inside of the rule area. Executing the ICs over split rule again, notice that it only flags the 2 DRAMs inside of my rule area. Users can now import rule areas, constraint areas, and keepouts from within Expedition Layout and Allegro directly into Hyperlinks DRC, and run Hyperlinks DRC rules inside or outside of these areas. This will save time running electrical rule checks in a smaller, targeted area of the PCB, which can significantly speed up the automated checking of larger, more dense PCBs. Other enhancements in this release include Python module support for external automation, which is a great enhancement for our Linux users of Hyperlinks DRC. This aligns Hyperlinks DRC to match the automation capabilities of our Hyperlinks SIPI tool. Some minor enhancements in this release are adding parameters to the SensorNet isolation rule and the in-group spacing rule to reduce the amount of false errors produced in earlier versions of these out-of-the-box rules. We've also enhanced the user layer support through the Expedition Flow that debuted in the previous release of Hyperlinks DRC. These new features and enhancements are new in Hyperlinks DRC 2510 release.